Hi everyone, it's time for part 3 of volumes. So this time we have a region. Again, I'm using root x. This time I have 1/2 x and I'm going just 0 to 4. I went a little smaller for the region just for funsies. But this time, instead of rotating around the x-axis, we're going to rotate around the y-axis. So first things first, I'm going to draw a sample rectangle. And my sample rectangle is going to be perpendicular to that axis of rotation. I'm rotating around y-axis, so karate chop, that way. So I have my sample rectangle is running this direction. So now when I spin this guy around, and I'm not going to try to draw this thing, it would look, I don't know, it would look like a cylinder from, or sorry, like a cone on the outside, but on the inside it would look like, I don't know, it doesn't have a name. Okay. So if I draw this guy and I spin it around the y-axis, my inside part is blue like that. I'm going to draw my thickness already. And then the red is on the outside, so I have this. And that thickness. So I have this same sort of shape as before. Remember this in our last video? And I'm going to totally steal from this. So it's that pi times the outer radius squared minus the inner radius squared, but not dx this time. Because if we look at our thickness, that skinny little rectangle right there, instead of a dx thickness, it's a dy. Our thickness is always dx or dy. If you ever decide to make it something else, you've just messed up. Okay, so stealing from this, though, I have that pi outer radius squared minus inner radius squared. I'm going to steal that, so I'm not going to recreate it all. Look back at the previous video if you're like, what's going on? So outer radius squared minus inner radius squared times the height. So our outer radius, you're going from the y-axis out to the red. And that's an x. I'm going out horizontally, so my outer radius is the red x. So if I have y equals 1/2 x, that means x is 2y. My inner radius is the blue. So I have, I'm looking at this piece here. So from the y-axis over to the curve. So my outer radius is that blue x, which is going to, if I solve this guy for x, I get x equals y squared. And that dy is going to be our boss. It tells us what to look at on all things. So we have, I'm going to come over here. So we have our pi, switch my colors, times my outer radius, which is an x. I'm going to just so I'm not having to say red x and blue x, I'm going to call that x1 and x2, just to give it a quick name. So x1 gets squared minus the x2, the blue guy, gets squared times the thickness dy. The dy is the boss, so it tells me I can't have x here. I need it to be y's. So it would not be wise to make a mistake on that. So our volume is going to be, we'll sum things up. I'll put my bounds in a second. So I have pi times my outer radius, which is the x1, which is 2y, minus my inner radius. I'm trying to minimize my clicking because it's super annoying. So my inside radius is y squared, and that gets squared. And then my bounds, remember that dy is the boss. So like this point right here is the point 4, 2. I don't care about the 4 at all. I only care about the 2 because the dy tells me, look at what y is doing. It's going 0 to 2. From here, we can clean it up a bit. So I'm going to move my pi to the front, 0 and 2. I will clean it up before I integrate. So 4y squared minus y to the 4th dy. I can integrate it. So I have 4/3 y cubed, forgot my pi, minus 1/5 y to the 5th. And that's from 0 to 2. And then I can plug in my 2. So I have pi times 4/3 times 2 cubed minus 1/5 times 2 to the 5th minus the 0. I like to put the minus 0 on just as a reminder because sometimes your bounds they don't just go away there. And this is a perfectly good answer, and I'm going to stop here.